Hello, I'm Professor Rad, and today we're going to use prime factorization to help us find a common denominator. So, compared to the other two methods that we've discussed, we can already see that this one is a little bit more complicated. So, the downside to this method is it is a little bit more roundabout and genuinely a little bit more complicated. I mean, our first method of getting a common denominator is just multiply the denominators. But one of the downsides to that is you can get denominators that are really big, and then that can cause issues later on. It can make the problems more difficult to do. So it might be better occasionally to do a little bit more roundabout work at the beginning so that we get denominators that are smaller, and that'll make operations easier in the future. So what we're going to do, since we're going to use the prime factorization to help us, we got to find the prime factorization of your denominators. Then look at all your denominators, and whichever one is smallest, we got to pick one to start with. So whichever denominator was the smallest one, we're going to use that as the base. And we're going to pick up all the prime factors from the base. Then we're going to go to the next fraction, the next biggest denominator. And we're going to see whatever factors from that one are missing from the base, and we're going to toss them in. And then we go to the next fraction, and whichever ones of those are missing to the new base, we're going to toss those in, and we're going to keep doing that. And then once we've finished, we're going to multiply all of those prime factors together. And not only will that get us a common denominator for all our fractions, but it will give us the smallest possible common denominator. So, it's a little bit weird to talk about in generality. So, if you want to pause and write these steps down or screenshot the page or something like that, feel free to do so. And then we'll go ahead and we'll apply the method. Okay. So we're going to use this method on 3 different examples. So our first example, we have 2 fractions, and then the other 2 examples will have 3 fractions, just so we can kind of see what this looks like in more and more complicated situations. So I'm going to start out with 4/21 and 11/45. And this method requires us to find the prime factorization of each denominator. So I'm going to make a factor tree of 21. And 21 is not bad. It's the same as 3 times 7. So we have 3 times 7 as my prime factorization. All right, we're going to do that now for 45. So 45 is going to split up into 5 times 9. And then 9 splits into 3 times 3. Okay, so 45 is the same as 5 times 3 times 3. Okay, so after you've got your prime factorizations, here's how you find the common denominator. Of the 2 fractions, 21 is the smaller one. So I'm going to start with that as my base. So I'm going to start with that 3 times 7. Then I look at the other prime factorization, and anything that's listed here already, I'm going to kind of like cross it out over here. So I've got 3 times 7. I notice that 3 is a factor here. So I'm going to say that this 3 is matching up with this one here. So this 3 is already listed. This 3 isn't matched up with anyone yet. And the 5 isn't matched up with anybody. So the factors that aren't matched up with anybody, I'm going to have to toss them in here. And then if I had a third fraction, I would continue and go through that process. So once I've done that, I multiply all of this through, and that's going to give me my common denominator. Ooh. So 3 times 7 times 5 times 3 It's going to give me 315. That is the smallest common denominator for 21 and 45. Now, even though 315 seems pretty big, right? So let's see what our first method would have given us. So our first method just says multiply the two. So 21 times 45 would have given us 945. So even though 315 is a pretty big common denominator, it's not nearly as big as 945. So it's big, but it's not the worst. Now, they also want us to rewrite each fraction with the common denominator. So I'm going to set up 4 21ths. And I've got to multiply it by something to get a denominator of 315. And then I have 11 45ths. And I'm going to multiply that by something to get a denominator of 315. Do you remember how to work through these? So we're going to take our desired denominator, in this case 315, and divide it by the denominator we have. That tells us what we need to multiply the bottom and the top by. And then 4 times 15 will give us our new numerator. So we get 60. For the second fraction, I can do 315 divided by 45. And that'll give me 7. And then 7 times 11 is 77. So our common denominator is 315. And when we rewrite them, we get 60 over 315 and 77 over 315. Okay. Let's do an example now that's got 3 fractions in it. So we're going to begin the same way by making a factor tree for each denominator. So my first denominator is 4, and that splits into 2 times 2. My second denominator is 6, and that splits into 2 times 3. Forgot to write out my prime factorization here. Let's do that. All right. And then my third fraction has a denominator of 15. And that splits into 3 times 5. Okay, so now we're going to use this technique to find our common denominator. So we're going to pick the smallest of the 3 numbers. In this case, 4 was the smallest. And we're going to start there as our base. Now, what we would like to do is we're going to go across and we're going to look at the prime factorization. And we're only going to throw in the prime factors that are missing. So for example, here I have a factor of 2. That can kind of match up here. And then I have a factor of 3. And there aren't any 3's to match. So I'm going to toss in a 3. In this denominator, we have a factor of 3. And we just threw a 3 in, so we have one to match. Then we have a 5, and there's no 5 to match up with. So we're going to toss in a 5. All right, so we've gone through all of them. So now we multiply them to get our common denominator. 2 times 2 times 3 times 5 is going to give us 60. So a common denominator for 4ths, 6ths, and 15ths is going to be using 60. All right, so now let's rewrite each of our fractions. We have 3/4, 7/6, and 4/15. Now, how many times does 4 go into 60? So if we do 60 and we divide that by 4, we're going to get 15. Three times 15 is 45. For the next one, how many times does 6 go into 60? Well, 60 divided by 6 is going to give us 10. And 7 times 10 is 70. And lastly, how many times does 15 go into 60? Well, 60 divided by 15 is 4. And 4 times 4 is 16. So 3/4 is the same as 45/60. 7/6 is 70/60. And 4/15 is 16/60. Okay, so why does this work? Why does this work so that we, first of all, get a common denominator and we ensure that it's the smallest? Well, what we're doing when you find a common denominator, what you're doing is you are finding a number that all of your denominators are factors of. So when we create our prime factorization, this is an alternate way of writing your denominator. 2 times 2 is the same as 4. And here's 4 lurking as a factor of our common denominator. 2 times 2 is 4, and so 4 times 15 will get you 60. 6 is the same as 2 times 3. So if I take this 2 times this 3, there's our 6 hiding out amongst our factors. So 6 times 10 will get me 60. And 15 is the same as 3 times 5. So here's the 15 lurking out as a factor. 15 times 4 will get me 60. Oh, excuse me. So this works first and foremost as a common denominator because everything that we have here ensures that all of these guys are factors of the common denominator. Excuse me again. So the process that we did of taking out of, adding in only the factors that we need. So making sure we add only the factors we need is what ensures that this is going to be the smallest possible denominator. You can make this bigger, of course, by adding some extra factors or some extra fluff. But when you do that, you won't get the smallest common denominator. So for example, back in the first video on this topic, we had the same 3 fractions, 3/4, 7/6, and 4/15. And in that case, our method was to multiply all 3 denominators together. And in that case, we got a common denominator of 360. So a question you might want to ask yourself when you're working with fractions is, do you care about working with really big numbers in the fraction? Or would you rather work with with as small possible numbers in the fraction that you could have? So that's kind of the decision you have to make. Our first method gave us a really easy technique, but it might make things harder for us in the future. Whereas this new technique of using the prime factorization, it's a little bit roundabout and it's kind of a long technique, but it's giving us smaller numbers to work with that in the future might be easier for us to deal with. So everything's kind of got a plus and a minus to it. So you just got to figure out which method works best for you and which you would prefer to use. So let's do one more example together of using this technique to get a common denominator. I'm going to walk through it step by step, but if you want to try it out on your own first, feel free to pause the video here and work through it. All right, so let's go through this one using the same technique. So we've got to get a prime factorization for each of these three denominators. So I'm going to start with 10. 10 is nice. It splits into 2 times 5. The next denominator is an 8. 8 splits into 2 times 4, and then 4 is going to break into 2 times 2. Ooh, let me make sure I'm writing these out here. And then the last one we've got is 20. So 20 splits into 2 times 10. And then 10 will split into 2 times 5. Okay. Next, let's start with our smallest fraction as our base. So in this case, or not smallest fraction, I'm sorry, smallest denominator for our base. So 8 is the smallest number, so let's start there. Okay. Let's look at 10 next. I usually like to go from smallest to biggest. So 10 has a factor of 2, and that can kind of match up with this guy here. And then we have a factor of 5, which isn't showing up, so we need to throw a 5 into the mix. Then from 20, we've got a 2, so that can pair up with this first 2. Then we have another 2. And then we have a 5. So something kind of weird's happening here. All of the factors that we need for 20 are already listed here. We need 2 2s and a 5, and we've got 2 2s and a 5. So that's our 20 hiding out amongst these factors. So I don't have to add anything at all for the 20. Okay, so 2 times 2 is 4, and 5 times 2 is 10, and 4 times 10 is 40. So our common denominator here is 40. All right, so let's rewrite each of our fractions with that common denominator. So we had 9/10, 5/8, oh my goodness, excuse me, and then 3/20. So what is 40 divided by 10? Well, that's going to be 4. So we'll multiply the bottom and the top by 4. 4 times 9 is 36. What's 40 divided by 8? That should be 5. And 5 times 5 is 25. And lastly, what's 40 divided by 20? Well, that's going to be 2. And 3 times 2 is 6. So 9/10 is the same as 36/40, 5/8 is 25/40, and 3/20 is the same as 6/40. All right. So we've got a few questions here for you to try out on your own. So see if you can use this technique to find a common denominator for 7/12 and 31/44. And then also use it to get a common denominator for 25ths, 35ths, and 21ths. In the next video, we're going to look at the next chapter and seeing where we can apply these common denominators. So now that we've done this work, why might we want to do so? Looking forward to seeing you then, and in the meantime, have a fabulous day. Bye for now.